everyone, welcome back to the next video in our NC Turbo Tech series, where we talk about all the details that go into what makes this kit stand out so well. Today, we're gonna talk about tuning. So that's gonna be what it took to put the tune together, why we did what we did. It's going to involve an interview with our OE level calibrator, Greg Banish of Calibrated Success. That does make it a little bit of a long one, but it's a very good one. So this one is definitely worth watching the whole thing. We're also going to go through some of the anticipated questions, so maybe we can answer some questions preemptively for you. So stay tuned. So the goal for the tune is the same as the goal for the kit. Make it as OE as possible. We don't want any kind of cobbled together, compromised anything. So that means smooth. That means smooth power, good drivability. That means safe. That means safe for both the engine and the catalytic converter, so you don't have to worry about durability and reliability. That means clean. So it's fully emissions legal everywhere, carb legal, no funny business. That also means it's reliable. So we don't have to worry about whether the engine is going to survive or not. So to go into a little bit more detail about all of that stuff and how we achieved those goals, let's talk to Greg Banish, our tuner. So he is in Detroit, where all of the OEs are, that factors in, and he's gonna be on the other side of a computer, but we've got a good long interview with him where we go through everything. Hey Greg, thank you very much for joining us today. We really appreciate your help on this project. Can you give us all an introduction and kind of why should we trust you to tune these cars for us?
I don't know if I trust me, but I'm Greg Banish. I'm from Calibrated Success. My background is mechanical engineering, so I have a degree in ME with an auto specialty from GMI, which is now Kettering University. So tons of credit hours there, tons of practical stuff there. And then after that, throughout my career, I've both run my own high-performance speed shop with a dyno, and I've worked at the OEMs. So my OEM work, every single job that we do at the OEM must pass emissions. It must be safe for customers to drive everywhere. So that same kind of approach has always been in the back of my mind, no matter what I'm doing. So it doesn't matter if I'm working on 100 horsepower or 1,000. It's still the same requirements, right? We don't give customers things that are unsafe. And I've been teaching because I had over the years several of these aha moments, like, oh my gosh, why didn't I know that before? You know, that now that I know that, geez, yeah, we should do that on everything we do going forward. So those aha moments kind of came together, and they went into my first book, and then there was a second book, and then a long time later I did a third book on diagnostics and emissions, just kind of trying to explain in plain English the things that we learn in the engineering area. And it's kind of funny because, like, early in my career, it never surprises me how dumb I used to be. We made cars run, sure, but for all the wrong reasons. Yeah. And once we realize the right way to do it, things actually get easier and cars drive better. And it's that skill set that made this project run as well as it did, right? You guys sent me one car to test. Yep. I did work on one car and sent you guys data. You guys had another car out in Colorado. And if we follow the rules, and those two cars are built the same, car A and car B should run about the same. And I feel like we had that kind of experience.
Yeah, absolutely. That's definitely what we saw here. It was crazy because every time you had some kind of update, we drop it in, it worked perfectly.
Yeah. So, and that was the goal, right? I wanted to make sure that I'm following the physics, because the physics are the same in Detroit as they are in Colorado, right? You guys happen to be a little bit higher barrel, but we have customers of this project eventually that will be somewhere in between the two of us, or they might be all the way down at sea level, right? And so again, that OE mindset, the car just needs to work everywhere all the time. And so there's some techniques that we use along the way to make sure that that's what really happens.
Absolutely. Yeah. So along those lines, can you walk us through what you did to set up this tune, what was necessary, how you worked physics into it and all that stuff?
Oh, 100%. So we always start with a stock OEM file, right? In this case, it's Mazda. They're pretty smart. They make millions of cars a year, and their cars all seem to run pretty well, and they pass emissions, and they're safe. Cool. What did we change? right? So I always start with what's changed and what do we know about the system? So of course we threw a turbocharger on that, but what does that really mean? Well, the turbocharger allows us to go up above atmospheric pressure going into the engine. So we know the load might have capped at about 100% before, but now we can go way over 100%. We shove more stuff in there. So a lot of the background tables we just had to extend or populate in the areas beyond 100%. You have to just tell the computer, hey, it's okay. And as you keep going out that way, there's going to be some sort of trend. And so we populate tables with trends as our first guess. We'll massage it later. Then we know we changed a couple other things, right? So one of the other things we know we changed was the mass airflow sensor. And even though it's the same physical sensor, as soon as we put it in a different location with a different pipe, the way that air flows across the sensing element versus the total air going through the whole pipe, that relationship's a little bit different. And somewhere deep inside the ECU, there's a thing called a transfer function. And so what it does is it looks as an input and it gives you an output. And here, let me actually share what we did here. This is actually the transfer function for your Flyin Miata mass airflow sensor in your Flyin Miata tube. So we sent this out to a third party for testing. We sent it over to Nick at PMAS, and luckily he's just about an hour away from me here in Michigan. But he's got a super sophisticated flow stand. Yeah, it's not just your average cylinder head flow stand. It's a NIST certified thing. He does this for a living. But we send it to him, and he knows the exact flow here in left column in kilograms per hour, and he measures the output voltage from it. And he gives us this exact data, right? And so this data is that mass airflow sensor in that pipe. We know it's not going to change, and it doesn't care what temperature, it doesn't care what pressure. So if we just put that data in, now we have an accurate airflow measurement. We know the turbo could flow more air than the original setup. Well, that's okay. We got some pretty big numbers over here in the flow column. So we transfer that into our tuning software. We put that in and we say, okay, boom, here you go. Now, anytime we start and run the engine, the ECU at least has a real number for airflow coming into it before it starts any of the other calculations. So we eliminated a ton of the error right away by just doing this.
On the MAF, one of the interesting things to me there is that we didn't send you just the tube. We sent you the entire cold side from the intercooler to the throttle body so that you could measure the system as a whole, as opposed to just this one component of it, which goes back to what you're talking about, the specific airflow in that setup.
Oh yeah, 100%. So we know that, we had this conversation offline before. I'm kind of taking it for granted.
Right.
The clocking, if there's any sort of bend in the pipe, changes where that sensing element is versus the entirety of the tube, right? And so as long as it's always in the same spot, it will remain consistent. So we marked everything for clocking as we took it off the car. We send it over to Nick. He flows it on the bench with all that clocking marks set up exactly as it was. So anything that would change the airflow near the sensing element, and it's predominantly that tube upstream of the MAF, right, because we've got a couple bends in there. And it's okay to have them as long as we account for it.
With the clocking that you mentioned there, that's something that we've also incorporated into the production kit, so that there are marks, so the customer, when they install their production kit, will have those marks, and that MAF sensor will be installed exactly as it was in the test on the flow bench. So their numbers are going to be the exact same. The tune works exactly as it should.
Yeah, I mean, you can see, if they clock it incorrectly, if they misalign it, number one, you can say, send me a picture so I can look and see. And we see, it's clocked 20 degrees off to the side, and all of a sudden the fuel trims are all plus 15% everywhere.
Yeah.
Right? But pretty uniformly off by some amount. We say, oh, well, could you please line that back up? And all of a sudden the fuel trims go to just about zero, right?
Exactly. Yeah.
So speaking of fuel, the other major thing we changed was the injectors, right? We know that the factory Mazda injectors that they selected to make about, 180 horsepower are not going to support our turbocharged horsepower. So very wisely, we picked some new higher flow injectors, but we need to know exactly what they do. And there's a lot more to how injectors flow than just a static flow rate. So at Calibrated Success, I've been preaching this for over a decade, probably 20 years now, of, hey, when we do the tuning process, we kind of got to take some of the unknowns out of the equation. And fuel injectors have about 4 different unknowns on how they operate. It's not just the slope, it's the intercept, it's the short pulse phenomena. And the only way to know all that is to have a pretty sophisticated flow stand like this guy here that runs the injectors and runs them at a variety of voltages and pulse widths. And we take tons and tons and tons of data. And when we process all that data, we collect it, and it gets us something that looks like this. And so you can see this black dotted line is kind of the nominal flow at 14 volts, but all these other rainbow colors are different voltages. So we can see how the voltage kind of shifts everything a little bit. And then we see this weird nonlinearity down here. We see how where the line intercepts here, nothing really comes out of the injector. In fact, not until we get over here to about 1.2 milliseconds does the injector even think of opening at all. And then it kind of rises a little steeper and then settles in over here. And that nonlinearity is unique to every injector design. And then on top of that, every manufacturer has a different way of describing that stuff. So they may have a short pulse adder in the time domain. They may have a low slope, a break point, and a high slope, or they may have a series of tables here. So we've got this injector base pulse width. And that kind of takes the flow rate into account, but we also found a couple gotchas in the software because there were some multipliers in the background of the software, some that we could see, some that we couldn't see. And so they bake some error into their number. So when I made this decoder ring software to figure that out, when I test a set of injectors and I know they're going on a Mazda, I know the right way to kind of unwind that and give you the number that you will plug in and work. So we get the injector base pulse width, we get a minimum opening time, we get this opening time here is that offset. This global multiplier, we end up setting to a 1.0. This flow rate didn't have a huge impact, but this other guy right here, this volumetric efficiency load multiplier, you can see how most of it's a 1, but at these first few rows here, we actually put some other numbers in, and that's where that's that idle and cruising pulse width area. And so that's how we get that nonlinearity to fall in line for very short pulses out of these big high flow injectors. And getting that right is one of those other steps. Now, the cool part is when we did all this, I just plugged in the mass air curve that we got from Nick and the injector data I got from my bench, put it in the software, and I started the car.
Exactly.
And
going back to your physics comments. Yeah.
Yeah. And I didn't have to change anything else. It idled at the same idle speed it would have before because, I mean, the engine, the pistons, and the spark plug don't know the turbocharger is there at idle, right? And it's getting a valid airflow measurement, and it has a valid fuel flow model. It just worked.
Exactly. Physics is amazing.
Yeah, so we did that, and so then we go and find all the areas. Now, this table doesn't stay all 1.0s everywhere forever. This is one of those tables I use to do some fine tuning later. And when we want to go past emissions, there's more to it than just kind of crossing your fingers and hoping that the fuel trims drag everything in line, right? So we try and drive all of those errors down to small numbers and leave the least amount of leftover stuff for the catalyst to clean up on the way out. And that was kind of the thrust of the program.
I guess along those lines, what have we done to prolong the life of the cat as part of this tune?
Well, number one is you have to remember how a catalyst works, right? They're a sponge for oxygen, and they make their own heat as we basically take unburned chunks of fuel with unburned oxygens, and they react inside the catalyst, right? So that's going to happen no matter what. And in fact, we want that to happen. That's how we clean up the tailpipe emissions. And so I want it to get up to temperature very quickly so that it can do that cleanup job. Number one, I want to probably not have a whole lot of leftover stuff, not a lot of leftover oxygen, not a lot of leftover fuel coming out of the engine. So my base tune is pretty close. But then if there is any leftover, because inevitably there will be, the cat is capable of reacting that off pretty quick. So we did some stuff in there to make sure that even though we put a turbocharger in between the engine and the cat still wakes up and goes to a workable temperature very rapidly. And so, we took data logs here, and this is just a sample of what we were doing. But you can see down on the bottom here, we have exhaust gas temp and we have catalyst temp, because the car you guys sent me was awesome. It was instrumented, right? We had a discussion about this beforehand. Instead of just looking at air fuel ratio or like an EGT probe up by the cylinder head, which doesn't help us, we had temperature and pressure coming into the turbo, and we had temperature coming out of the turbo, going into the catalyst. We had temperature in the middle of the catalyst, which is, as an OEM, the number we're worried about because those cats make their own temperature. And so we tested and we kind of check kind of worst case. We feed it lots of fuel, lots of oxygen, lots of fuel, lots of oxygen, and we watch and see what our air fuel ratio does. So like this white line is my air fuel ratio. You can see here, I was at about 4,200 RPM. We were at 174 kPa, so we're making some pretty good boost here. A lot of power. And our air fuel ratio was about lambda 75. And people go, oh my gosh, that's pig rich. No, it's appropriate because we're monitoring not only the gas temp down here on the bottom, so that's this orange one at about 700 centigrade, and you see it was still going up, but also the catalyst midbed. And the catalyst kind of lags a little bit, and it's kind of a heat sink, so it's slow to warm up, but it's also slow to cool down. We put extra fuel in at Watt to make sure that we cannot burn the catalyst out of the car, because a melted cat does no work, right? It doesn't clean up our tailpipe, and they pollute like mad. One of the cool things about this car is, the cat really didn't represent any significant back pressure. So we weren't losing power by having the catalyst in there. In fact, the muffler has more back pressure than the catalyst. And the car doesn't stink, right? You can just drive this car like a normal car,
Yeah,
so,
exactly.
And then, oh, by the way, we make ARB happy, right? So we're legal to sell wherever we want because we meet the current emission standard for this vehicle.
Yeah, exactly.
So that was us, trying to check, all these weird conditions. This dyno log that you see here is actually a pretty long recording of me driving back from the dyno. So right before all of this, I was strapped to the dyno making the horsepower. And so you guys know how much power this thing made. And this was actually on the elevated boost level, as you can see, 174 kPa. That's pretty sporty. And so we were just recording all this stuff, and I'm looking at all these excursions in temperature, right? And what does the cat temp do over time? And oh, the cat, even as I dropped off here, the cat temp was still rising. Well, how high does that rise? Does it ever get to the danger zone? So there's some threshold that I don't want it to ever get to or get beyond, right? And so I'm looking for that under these real world driving situations. So you can see my vehicle speed went down to 0, and then I accelerated again. And, here I had a pretty sporty acceleration, and then I had some coast down. And all these things can do weird stuff to catalyst temperature differently than just exhaust temperature. So the care and feeding of the catalyst is kind of important if you want to live a long, happy life.
What kind of things have you done to keep the engine happy and safe?
Again, it kind of goes back to that air fuel ratio. So we look at this, white is my air fuel ratio. So you can see where the loads went high, and I could go here again. You can see that the more time we spend at load, hey, this thing's probably going to go to a little bit richer ratio here. So again, that went to about 75 lambda. So it can go pretty rich, but this is a fairly highly stressed small displacement engine. So that's appropriate. We're not misfiring or anything crazy like that. And then, if we really wanted to, we could look at ignition timing. And ignition timing advance when we do the same thing, 29 degrees at that point, but that was 65 kPa, so part load. So if we go back to our high load event over here, you can see that we picked an ignition timing event here. This one here is about 5 degrees at that point. And you say, oh, 5 degrees, that's not a whole lot of timing. Well, it doesn't need it. We're at 174 kPa. The stuff is crammed in the cylinder. It's a fairly small bore engine compared to, I don't know, your garden variety V8 that we play with a lot as well. And so it doesn't take a whole lot of time for the flame to get from that spark plug right in the center out to the walls, especially when everything's crammed in there and the burn rate's pretty high. So as it turns out, 5 is just the right answer for this. And then we've got knock sensors, and we're looking for knock activity, and we have a couple other ways of monitoring that along the way. But my rule is don't knock, right? And we ran this on the appropriate fuel. So in this case, it was on 91 octane because that's the premium that most people can get. I'm in Michigan. I could get 93, right? All my pumps here tend to have 93. So I know that this car does run a little bit better with another degree or two of timing in it. And I could put that in here, but we deliver it with a pretty solid calibration that just works for anybody. So, you know, if you sell to somebody in LA and all they get is 91, Colorado, you guys only get 91, right? Depending on which station and what altitude you're at, right?
Yeah.
Some of your stations seem to think that 89 is the limit.
Yeah, there's some scary ones out here. We just avoid those.
Yeah, but I mean, here's the thing is even if you put 89 in this car, the knock sensor will probably hear it, dial it back a little bit further, and you'll be safe, right?
Yeah.
We're not starting from a super aggressive point,
Yeah.
but we put the appropriate amount of spark in there for that application, right? So,
sorry, how much better would it be if it was optimized for 93 octane?
there's probably another 10 horsepower in there.
Okay.
We're going to under promise and over deliver is our thing at the time, right?
Yeah.
If
Exactly.
a customer puts 93 in their tank, it's just never going to tickle a knock sensor is my goal, right? So on 91, once in a while, you'll see a little bit of knock sensor activity, and that's okay, but nothing significant, right? It's not trying to pull, oh my gosh, I got to pull 5 degrees out to get control of this thing. Well, I just think it's great that Flyin Miata has decided that they're a leader in the industry on this one, right? They're being very proactive on the emissions compliance and the responsibility, right? We know CARB is looking for easy targets. We don't want to be an easy target, so nobody wants an enforcement action. It just costs lots of time and lots of money. And, even if you proved yourself right, you would still be out $100,000 plus in legal fees just to prove that you were right.
Exactly.
Mr. Miyagi say best block, no be there, right? And we found a way to make very impressive horsepower for these street-driven cars without ruining the emissions. So why not, right? It's cool. And if we want to leave a hobby for the next generation, we're going to have to be responsible this way, right? So I've been having that discussion more and more with some of the SEMA crowd and the Hot Rod Magazine crowd. And so that's, that image of responsibility and preserving things for the next generation, I think is pretty powerful. And I really love working with companies like you guys where you see that and you're walking the walk, right?
Yeah, exactly. Okay, so what kind of protections are built into the tune?
Well, again, because we did all this work logging and checking temperatures and pressures along the way, those drive the fundamental calibration that we come up with, the feed forward, before any corrections, is safe because we've monitored it. We've looked for knock ahead of time. We put the bad gas into it and said, how much does the bad gas move it versus the medium gas versus the good gas, right? I could just as easily just, put 93 in the tank, tune it till it, starts to knock a little bit and call, there you go. And, ship it. And chances are it'd be all right for most people, most places, but, look, is the last 5 or 10 horsepower really worth it? This car is a riot in traffic. And the power to weight ratio is so good. And even, you told me NC is like the heaviest of the Miatas, right? But it's good. It's, it just works. In fact, the car doesn't even need as much final axle ratio as it has. It could have a taller gear in it. It would still be fun.
Especially with this thing attached to it. So
well, I mean, I think adding the turbo is what makes this car, it hits, I'm a little jaded, right? My summertime daily driver is 6.2 liters with twin turbos.
Yeah. It's a little different game.
I'm used to just not having traction until triple digits, right? So this thing has traction, but to drive it in traffic is very point and shoot. It's a lot of fun. But that safety, look, could we go leaner on air fuel ratio? Sure. But what would it do? It would drive the EGTs up. It would drive the catalyst temp up, and it would shorten the catalyst life, right? And we risk burning the cat right out of it. On the bad side is not only would it potentially just burn the cat out and increase the emissions, but if you melt the cat in place, it turns into a moon rock and nothing flows past it, right? So now you're down to 0 horsepower.
Yeah.
Right? And oh, by the way, a $2,000 repair.
Yeah,
Sucks.
Exactly. Yes,
right? So
it does.
We don't want to do that to our customers. So the safeties were all that logging that I showed you, all those drives, right? Going to the dyno, just trying to find the corner cases, right? Hot, high altitude, cold, high altitude, hot, low altitude, cold, low altitude, right? we had the video I shared a while ago of doing a cold start on this thing, right? We had a foot of snow
Yeah.
here in Detroit, and I had to brush the snow off the car, reach in and start it, and the thing fired right up. That's the expectation, right? When you go buy a car from the dealership, well, of course my car should start. But for some reason in the aftermarket, it's a surprise when that happens, right?
Exactly.
Like, no,
Exactly.
that's our requirement. So the safeties are really that we did our job right in the first place. Right? This is not a one afternoon dyno tune. This was a lot of work.
Absolutely. Absolutely. So along those lines, then why don't we have any of the fancy add-on stuff, launch control, flat shift, that kind of thing?
The flat shift causes misfires. We got to be really careful with this, right? So flat shift is a fuel cut. It's really just hitting the rev limiter.
Yep, exactly.
And so if you go fully enriched and you cut the fuel, what you've done is you've loaded the catalyst with lots of fuel. And then you put a really hot shot of oxygen into a hot catalyst with hot fuel. And guess what happens, right? That's what we call the Bessemer process. It's the process that they use to melt steel in the mills. What's going to happen to our catalyst if we do that, right? So yeah, pops and bangs, woohoo, until the last pop is your catalyst going out the tailpipe, right? And now that was $2,000, please, to fix it.
Yeah, yeah, exactly, exactly.
Yeah, so we'd rather just not. You know, a little bit of burble on decel, no problem. We're not hurting anything, but that pop, 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 you know, sitting on a two-step is a great way to destroy emissions equipment, right? In fact, at the OEM, we call it catalyst damage misfire when it's happening. You get the blink check engine light at that point, right? So, you know, as much as it would be nice, how much is it really going to change how fast this car is, you know, what at the drag strip? It's not going to make a huge change on our elapsed time or even our mile an hour. And the risk was just frankly not worth it, right?
Yeah. Well, just one last question for you then to kind of preempt the customer question, I guess. What would a customer need to do tuning wise if they put a bigger exhaust on it or some other realistic modification? We're not talking about different injectors and that because that's a big can of worms. But you know, I had the stock exhaust. Now I've got this free flowing muffler. What do I need to change in the tune to account for that?
If it's downstream of the catalyst, no change.
Yeah.
Doesn't
and that goes back to the physics thing.
Yeah, well, the physics is, remember how the computer works. The computer has a mass airflow sensor. So we spent the money to get this finely calibrated MAF in the right tube, calibrated to that tube and its geometry. Air still have to go in through that sensor and get measured. So if the restriction was out on the backside at the muffler, and you got rid of that, we would simply let more in here and more out there. We would measure higher airflow, and we would give it the fuel because we have enough injector for that. It just works. And
there you go. Exactly.
Oh, by the way, you know, the pressure ratio across the turbine gets a little better, so your spool time will get shorter. So it'll spool a little bit faster with a sportier catback on it.
Yeah.
You'll hear interesting noises out of the car a little bit more with a you know, so you'll get some of that exhaust burble that would otherwise be masked by the factory muffler. But generally speaking, turbos like sewer pipes after them. So, I mean, system efficiency gets better when you do that. So that's good.
Yeah. And it's all measured by everything. So it's all advantages with no need to retune or worry about it. You just bolt it on and go.
And in fact, what we found was switching between two different AR housings on the turbo didn't even change the tune, right?
Exactly.
You know, it responds to the actual instantaneous airflow, the percent load in the cylinder, and to a lesser extent, the manifold pressure. Right?
Yeah.
So those are all being measured in real time. So if you get rid of a restriction on the backside, or it's a little slower to come up or a little faster to come up, the system just reads and reacts because it's following the physics.
Yeah, exactly. The OEMs, like you said, do not tune individually for each car. They just put one tune in it and send it out for those million cars because the system adjusts for things as needed.
Yeah, and then how many millions of people have put a new muffler or catback on their car with no change, right? This is the same. We treat this car as an OEM turbocharged delivery at this point. So if the check engine light comes on for some reason, right? What do? We grab our diagnostic tool, and we scan and we look for the code the same way we would if it was a Mazda Speed 3. right?
Mhm.
And we've had that case here, right, with our development vehicles where, oh, something went wrong. Oh, well, the code
Yeah.
says that, oh, I found it. Never mind. Okay, good.
Exactly. It worked just like Mazda intended. There's a code, chase it down. Oh, this thing went wrong. Not in the tune, just this thing went wrong with the car. We fix it. We didn't change anything on the tune. Now the code is gone and doesn't come back because we fixed the problem, just like the OE car.
Yep. Yeah. So, I
Yep.
mean, we could have a hose that's off. We could have, a vacuum line, a sensor unplugged. And
Yep.
yeah, we'll detect it just like, because we keep all of the diagnostics active, because that's part of
Absolutely.
the EO process is all
Yep.
those diagnostics have to be active.
Absolutely.
If it's got a
Absolutely.
misfire, there's a reason.
Mm-hmm. Yeah. Yeah. It's not a tune problem. It's a car problem. Greg, thank you again for joining us for this. You're obviously in Detroit, very far away. So thanks to modern technology, we can do it from opposite sides of computers here. But we really appreciate everything you did on the project. The car is phenomenal. We're so happy with it. And again, thank you for all the insight here. That was awesome. We will definitely keep your number on speed dial for the next project. So stay tuned for that one.
All right. Thanks for the opportunity, Brandon. It's been great working with you guys.
So we wanted to give you a run through of all the sensors that Greg talked about and some that he didn't, so you knew exactly how we made sure that the kit was good and solid and performed well from a tuning standpoint, but also from like a functionality of the parts standpoint. Now, first off, you recognize this car. This is Nancy. This is our development car. This is Mike's car. This is our other development car. So this is the car that we shipped to Greg in Detroit for him to play with for months to make sure that everything got dialed in. So in order to verify that the filter didn't have too much restriction, that the air temp was appropriate, be sure to check out our thermal management video for more info there. We have a pressure sensor and a temperature sensor right behind the air filter here. Going into the exhaust, we have a pressure sensor and an EGT probe, exhaust gas temperature, in front of the turbo, right in front of the turbo, and then we also have those two behind the turbo, again, pressure and temperature, and like Greg mentioned, the temperature sensor is right in the middle of the catalytic converter so that we can make sure that its temperature was safe. We also had an ambient air temperature sensor back in here to see how hot it was by the brake lines to make sure that we're safe with all of that. We have on the intercooler, we have temperature and pressure on both sides of the intercooler. And then there's also what Banks calls an air mouse, which is basically a weather station. So humidity, air temp, all that fun stuff so that we can make sure that all of our numbers were accurate. Now, all of this stuff we logged on our Banks iDash setup. So we're able to pull everything out of the OBD2 system in the stock computer, and then also the extra information that we needed that I just talked about. So with all of that together, that was a crucial part in making sure that the tune was safe and making sure that the kit was as effective as possible. Last but not least, we had engine oil temp to make sure that that stayed under control. We talked a lot about the tune and how good it is, but we haven't really talked about how you get the tune into your car. The good news is it's very easy. So we use Versatuner software. Now, we did have to work with them to modify the software in order to give us access to everything that we need. So it's not the same thing as the Versatuner that we started off with. That said, you need a cable that we include. You plug that cable into your laptop. Does have to be a PC, won't work with a Mac, sorry guys. And you load that into your car. That's it. We'll talk about the specifics in the instructions video, but that's all that's needed. Now, it's important to note that, like we said, this tune is based in physics. We don't need to retune for each car individually. It's built right to start off with, just like Mazda did, so there is one tune for all NC Miatas. Now, there's an NC1 version and NC2 and 3, but the physics in there is the exact same, so it does not need to be retuned to your specific car with your specific situation because it's just right to start off with. So we tried to anticipate some of the questions that we would likely get about this tune. As always, if you have more questions, drop them in the comments, reach out to our customer support staff, and we'll get them answered. We'll get your specific question answered. But to kind of preempt some of the questions, we're going to go through a few. So the first question is, can I run more boost? So the tune, as Greg mentioned, the tune is calibrated a bit above our target boost level. So you'll be safe if you run a little more boost, but we don't recommend running a lot more boost. The tune is not calibrated to that. What about boost creep? Is that an issue? Well, we took the entire exhaust system behind the primary cat off of this car. It's very noisy, but the boost was still totally under control. So boost creep is not an issue. What if I want to retune it? Don't. We have invested a wild amount of time and energy and resources to have the most professional, complete, safe, effective tune possible, as Greg mentioned, with all the different stuff. So we would really strongly recommend not retuning the car. Also bear in mind that if you retune the car, it is not emissions legal unless that specific tune is approved on this specific turbo kit. So the likelihood of that is very slim. What about NC1 durability? So the 2006 to 2008 cars, they have a little bit different engine, so it's not quite as robust. You should still be fine. I would recommend running lower boost, stick around 8 PSI or so, but we have a ton of miles in our old supercharged cars, and we have our NC1 development car right behind us over here that is also proving that the kit works fine on an NC1 at that lower boost level. Now, if you have more questions, again, drop them in the comments, reach out to our customer support staff. We are more than happy to answer any questions you have. Hopefully this gives you some insight into what we did with the tuning, how we did it, and why that makes this kit so safe, clean, and effective. Now, remember, this is part of our 4-part NC Turbo video series. So we have a video on the thermal management. We have a video on the turbo assembly, the outlet, and all that fun stuff. We have a video on the kit layout, so how all the intercooler hoses laid out in there, why we did what we did with all of that. Be sure to check those out in the playlist. Don't forget that we also have our installation video, so be sure to check that out if you want a step-by-step for exactly what you need to do, every last detail to install this kit in your car. As always, if you have comments, if you have questions, be sure to drop them in the comments below or reach out to our customer support staff. We would be more than happy to help you. We are very excited about this kit and cannot wait to see what everybody else thinks of it. Be sure to stop in for our next videos, and we will see you next time.